Hi friend, welcome back to my channel. In today's calculation series, we shall be answering some of the high physics questions you must be conversant with as you are preparing for any of your physics exam. So without wasting time, we'll be getting to physics calculation series 3. So let's get down to question number 1. It reads, they said a force of magnitude 500 Newton is applied to the free end of a spiral spring of force constant 1 times 10 raised to power 4 Newton per meter. Now what is the question? Calculate the energy stored in the stressed spring. Calculate the energy stored in the stressed spring. So we are asked to find energy stored. That is the question we are asked to find. So first thing first, for a physics question, when you are given a physics question, the first thing I advise you to do is to write out all the parameters that was given in the question. So for this very question, we'll say solution. If you go over the question again, let's see what was given. It said a force of magnitude 500 Newton. So force was given in this question. We'll come here and write capital F. And what is the value? We'll say equals to 500 Newton. So we have gotten our first parameter from this question. Now what's next? They said that force is applied to the free end of a spiral spring. So they draw it downward, okay, of force constant 1 times 10 raised to power 4 Newton per meter. Now in case you don't know, this question is from the topic called elasticity. Elasticity. That is where this question we are solving is from. Now from elasticity, we're told that force constant has a symbol, okay, and the symbol for force constant is K. So we'll write K. So any value that follow will be the value for K, and in this case our K is what? 1 times 10 raised to power 4 Newton per meter. So we'll write 1 times 10 raised to power 4 Newton per meter, comma. Now mind you, in case they did not write it as force constant, they can also call it elastic constant, or they can also call it stiffness. So whether they say force constant, elastic constant, stiffness, they are referring to K, okay, and this is the value for it in this question. So we move on. Then I said calculate the energy stored. So energy stored in this very question is unknown. Okay. So how do we solve if this is all we know or have regarding this very question? We are asked to find energy. Now, is there a formula for energy stored under elasticity? There are many formulas we can use to find the energy stored in a spiral spring. Now, because we're giving force and because we're giving force constant, the formula we will use will be 1 over 2 F squared over K. But I won't keep you in ignorance. There are many formulas for energy stored, one of which is 1 over 2 F, okay, times E. This is one formula for finding energy stored. Then we can also say it's equals to 1 over 2 K E squared. This is another formula for finding energy stored. Then we can also say it's equals to 1 over 2 F squared divided by K. So these are the numerous formula we can use to find energy stored. And these same formulas can also be used when you are asked to find the work done in an elastic spring. So take note, energy stored or work done, you can use all these formula. Okay, so which of them do you think we are going to use for this very question? We have F and we have K. Which of them has both F and K at the same time? Is it this formula? No. Is it this? No. Is it this? Yes. If you look closely, we have F and we have K. So we'll now come and write energy is equals to what? What do we have here? We have 1 over 2, the force squared over the elastic constant, or you say force constant. So guys, we have come a long way here. We have succeeded in picking the right formula for this question. So what next do we do? The values for each of these parameters, we are going to be substituting them into this very formula. So let's do that right away. To now be equals to 1 all over 2, because that's what they wrote here, okay, times, then what do you have up? Up here, you have F squared. So whatever is our F, we'll put it as our numerator. Our F in this question is what? 500 Newton. So we'll come here and write 500 Newton. Now they say we should square it, so I'll say raised to power 2. Are you seeing that? Now the fraction will be divided by the value of the first constant. We have to divide by the value of the first constant. So I'll come here and write over. What is the value for the first constant we have? Our value is 1 times 10 raised to power 4. 1 times 10 raised to power 4. So I'll write 1 times 10 raised to power 4. So you have to be very, very careful here. We have succeeded in answering the physics part of this question, and we are left with the mathematics part. So you have to be very careful in your further manipulation of this question. So what do we do, guys? Watch out. We'll now say is equals to, what do you have here? You have 1 over 2 times, watch out, keep watching out. 500 squared means, when you are asked to find the square of a number, it's that number times itself twice. So a squared means a times a. B squared means b times b. So 500 squared here means what? 500 times 500. So that is what we now have as our numerator. Now this guy here means 1 times 10 raised to power 4. 10 raised to power 4, we are asked to raise a number to a certain power. It is that number in the power. So the number of times the power was given. So look at what I mean here. The number to the number of times the power was given us. So if it's 10 raised to power 4, it is 10 in 4 places. That is 10 times 10 times 10 times 10. Okay? If it's 10 raised to power 3, it is 10 in 3 places. So this is how the expansion will now look like. We will now say 1 times, in place of 10 raised to power 4, we say 1, 0, 0, 0, 0. How many 0? We now have 4 0. Or you can say 10 times 10 times 10 times 10. Okay? That is it. Now from here, how do we now simplify? How do we now simplify? Watch out. We have zeros up here. We have 0 down here. So we can say this 0 we cancel this 0. This 0 we cancel this 0. Now this very 0 here can also cancel this very 0 there. And this 0 here can cancel this very 0 there. So what are we now going to be left with? Let's check out for that. We'll now say it's equals to, if you check closely, we still have our 1 over 2. So I'll say 1 over 2 times, if you check closely, what is left here as your numerator is 5 times 5. So we still have 5 times 5. 5 times 5 will give us what? 25. So we'll come here and write 25 over. Now 1 times 1 is what we have as the denominator. 1 times 1 will give us 1. So what is left here is over 1. So how do you now simplify further? From our knowledge of mathematics, numerator with times numerator, denominator with times denominator. And that is how you multiply fractions. So we say 1 times 25, that gives us 25, because any number times 1 is going to be that same number. Now over 2 times 1, that will give us 2, based on that same rule. Based on that same rule. Okay? So mind you, we are finding energy stored. Okay? Don't forget that. That is what we are asked to find. We are asked to find the energy stored. So how do we now solve? Now that we have gotten to this extent, what do we do to get our answer? We'll now say it's equals to 25 divided by 2. Let's get that in decimal. 25 divided by 2 gives us 12.5. So this is the answer in decimal, 12.5. And do we stop here? No. We have to add the unit for energy stored. Now the unit for energy generally is the joule. Is joule. Joule. So when we are done, we'll write capital J to show that this answer is in joule. And this is the answer to this very question. It's very easy. It's not difficult. So we are going straight to question number 2. Let's see what we have here. The question read, they said, a catapult used to hold a stone of mass 5 500 gram is extended by 20 cm with an applied force F. So applied force in this question is unknown. It was given as F. Now what is the question? They said if the stone leaves with a velocity of 40 meter per second, calculate the value of F. So in this question, we are asked to finally get the value of the applied force F. That is what is unknown in this very question. So like I always say, for a physics question, the very first thing to do is what? Is to write out all that was given in the question. So let's go to that right now. They said a catapult used to hold a stone of mass 500 gram. So we're giving mass, is it not? Yes. So come here and write M is equals to, what's the value they gave us as? They said it's 500 gram. Now before we progress and look for the next parameter, it is important to take note of something. In physics, there is what they call the Standard International Unit or the SI unit. For each physical quantity, they have their Standard International Unit. And in most questions, typically in this one we are faced with, it's advisable you make sure that every physical quantity is in their Standard International Unit. Now for mass, is gram the Standard International Unit for mass? The answer is no. Rather, the Standard International Unit for mass is kg. So what do I do from this very point? I will look for a means to convert from what I have to what I want. From gram to what? Kilogram. From gram to kilogram. And the only way I can do that is to divide the value I have here by 1000. So I will show you my work here. I will say 500, which is my given value, over 1000. Let's see what that will give me. 500 divided by 1000. That gives me in decimal. That gives me 0.5 kg. Mind you, once I've done my conversion, I will now leave it in what? Kg. And kg is the SI unit for mass. So now I've done this, guys, I am free to progress. What next was given in the question? They said is extended by 20 cm. So this is the next value that was given in this question. Now guys, look at something. From the topic from which this question was given, the topic is also elasticity. Now, there is something to take note of. Whenever you see the word extended by, emphasis on the by, or let's say they say compressed by, or they say stretched by, the value that follow after will be for what is called extension. There is a physical quantity under this topic called extension. So any value that follow will be the value for the extension. Okay, so in this case our extension is what they said is 20 cm. Now also check, extension is a form of length, true or false? The answer is true. Now ask yourself, is centimeter the unit this value was given? Is it the standard unit for length? The answer is no. So the best thing to do in this case is to convert from centimeter to the SI unit for length, and that is meter. And in this case, the way to get that is to divide your given value by 100. So we're giving 20. We'll now say 20 divided by 100. Whatever we now get will now be in meter. So let's do that quickly. 20 divided by 100. That gives us 0.2. So come and write equals to 0.2. And what will now be the unit? Meter. And this is the standard unit for length. So our extension, the one we are going to use to solve, is 0.2 meter, not 20 centimeter. I hope that is clear. Then I said with an applied force F. Then I said if the stone leaves with a velocity of 40 meter per second, this is the next given quantity. So we're given a velocity of 40 meter per second. So in this very question, velocity is known. Yes or yes? Yes. So we say equals to what? What do you have here? 40 meter per second. So that is for that. And mind you, meter per second is the standard unit for velocity. So we are not converting anything. I hope that is clear. And the question now says, calculate the value of F. Calculate the value of what? F. F, based on the question, is what? The applied force. So in this case, our applied force F is unknown. So guys, that is all for what was given in this very question. So if you ask me, we have mass, we have the extension, we have velocity, and force is unknown. How do we get the answer to this very question? Now we'll start from the unknown, force. Force. Now, do we know anything about force under elasticity? Okay, we know that from Hooke's law, we can say force is equals to elastic constant times extension. Force is equals to elastic constant times extension. But in this case, were we giving elastic constant? No, we're not giving our elastic constant. So we cannot use this formula to get our answer. We cannot use it. Now, ask yourself, observe something. The stone was put in a catapult and it was stretched. Now, that moment the stone is in the stretched position, what form of energy do you think it has? The answer is what? Potential energy. Okay? Now, the moment the stone was released, what form of energy it's now moving with? The answer is what? Kinetic energy. So there is a conversion in energy from potential energy into kinetic energy. And there's a law in physics that governs this. That law is called the law of conservation of energy. And it simply states that the total potential energy is equals to the total kinetic energy. And that brings us to this very formula that we have here. And this is the one we are going to use to solve the question because it defines the scenario here. Now ask yourself, is there a formula for potential energy under the topic called elasticity? There are many formulas for potential energy. But based on the fact that we're given mass and we know our extension and we're given velocity, which formula do you think we can actually use to get our potential energy from this very question? Now observe something. Since we know our velocity and our mass, we can get our kinetic energy. Okay? And we also know that potential energy, okay, is equals to, based on what we're taught in elasticity, the total work done. So we can actually make use of some of the formula for work done to get our potential energy. And mind you, I've already given you formulas before. Because of the fact that we're giving force is what we are trying to look for. The formula for work done we'll be using is equals to 1/2 force times extension. Because in this one you have force, and in this one you also have extension. So we're going to be saying that the potential energy is equals to kinetic energy. What is the usual formula for kinetic energy? Kinetic energy is what? 1/2 mass times velocity squared. So this formula we'll be saying is equals to this formula. I hope that is clear. This formula will be equals to this. So let's write that out. In place of PE, we'll write 1/2 F times E, okay, equals to, what do you have for in place of the kinetic energy? We have 1/2 mass times velocity squared. So guys, observe something. We have our formulas for potential energy and that for kinetic energy. So how do we now solve from this very point? We will now impute the values for what was given into this very formula. Let's do that right away. So we'll say 1/2 times, in place of force, do we have a value for it? No. So we'll leave it as F. Now in place of extension, what is the value given? 20 cm. And when we convert it to SI unit, we have what? 0.2 meter. So this is the one we are working with. We'll come and put it here. 0.2. We'll now say it's equals to, based on what we have there. equals to 1/2 times, what do you have here? M. What's the value for M? We're giving M as 500 gram, but we converted to XI, and the value we have for the XI unit is what? 0.5. And that is what we are working with. Now, what else was given? Velocity squared. Do we have a value for our velocity? Our velocity is 40. So come here and write 40. But do we stop there? They say we should square the velocity. So raised to power 2. Hope you are seeing that. So from here, what will happen? Watch out. 1/2 times, what do you call it? 0.2 will give us what? 1/2 times 0.2 give us 0.1. So in place of this, we now say force times 0.1. Mind you, we are trying to simplify everything. It will now be equals to, now all this will be run once. The square of 40 is what? So we are trying to conserve space. The square of 40, 40 squared means 40 times 40. So let's see what that will give us. 40 times 40 give us 1,600. Now that is what we now have in place of this. Okay? Then what do we do? Times 0.5. I'm trying to simplify everything and get a single value. Times 0.5. It gives us 800. Now times half or divided by 2. It now gives us finally 400. So this is the simplified form. Now mind you, we are asked to look for F. So we are not going to stop here, is it not? How do we now get our F from this very point? The thing to do, because you have F times 0.1 on this side, the best thing to do is to divide both sides by what is attached to F. And that is 0.1. So over 0.1 over 0.1. Now watch what will now happen. 0.1 here will cancel 0.1 here. So F will be equals to what? 400 over 0.1. And let's see what that will give us. 400 divided by 0.1 gives us 4,000. So we'll write 4,000. Now guys, this is the answer to this question. Our force is 4,000. But do we stop here? No. We have to add the unit for this very force. Force, the unit for force is what? Newton. So we'll put capital N. And this is the answer to this very question. It is very, very, very easy and simple. So guys, I hope you understand how this very question was solved. In fact now guys, we'll be getting to the next question. And that will bring us to question number 3. Alright guys, here is the next question we are asked to solve. It reads, an electric device is rated 2000 watts, 250 volts. The correct fuse rating of the device is, so we are asked to find the fuse rating of the device. So we'll say solution guys. Now when you have this question, let's see what was given in the question. The question with an electric device is rated 2000 watts. Watt is unit for which physical quantity? Power. So we'll say our power was given to be 2000 watts. So guys, that is the first quantity given. Now what else? They said, and 250 volts. That is for our potential difference. Okay? Our volt was given to be what? 250 volts. Now the question says the correct fuse rating of the device is, so we are asked to find the fuse rating. But come to think of it, what do they really mean by the word fuse rating? Now if you've seen a fuse is an instrument that is attached to most electrical appliances that determines the maximum amount of current that can be allowed into that appliance. Okay? So in this place, we are asked to find the maximum current that the fuse can allow. So that's why it's called the fuse rating. So instead of me spelling it out as fuse rating, I will simply write I is unknown, where I stand for the current. And the current is what will tell us what the fuse rating will be. So either ways, whether they call it fuse rating or they choose to call it current rating, is the same thing they are referring to. That is the line I'm trying to draw here. So in this case, our current is unknown. Now we have power. We have voltage, also called potential difference, and our current is unknown. What formula do you think we can actually use to solve this question? Now, before we continue, this question is from the topic called electricity. Okay, electricity. That is where this question was gotten from. Now, under electricity, the formula that connects power with voltage and current is that power is simply equals to current times voltage. And this is the formula we'll be making use of because it's all encompassing. It has all these parameters in it at the same time. Now, what do we do? The basic thing to do is to substitute all these into this formula. So we say in place of P, what do we put? 2000, is it not? So we say 2000 is equals to, in place of I, do we have any value to put for it? No. So we leave it as I. Okay? We leave it as I. Now, times, in place of potential difference, what value do we have for it? They said it's 250 volts. So guys, we have made a little progress. We have got to this place. Now, what next should we do? The next thing to do is to make I, which is current, the subject of this equation. How do we do that? We are going to divide both sides. Dividing both sides by what? What is attached to I? And guys, what is attached to I here is what? 250. So we'll say over 250 over 250. So this is what we now have. So what will now happen? 250 here, we cancel 250 here. What is left on this side? We just have I. And then what is left on this other side? We have 2000 over 250. So guys, we have made another progress again. Do we stop here? No. How do we now progress? We now say I is equals to 2000 divided by 250. We can get that directly from our calculator. That gives us exactly 8. So we say 8. And do we stop here? No. We have to add the unit for current. The unit for current is ampere. The unit for current is ampere. Okay, symbolized by capital A. So after we've gotten our answer as 8, we'll say 8A. And this is the answer to the question. So the fuse rating of the device is what? 8 ampere. I hope this is clearly understood by us. So let's get straight to question number 4. Solution. Now this question read and we solve. They said an electric bell is rated 100 watts and 220 volts. So we start deriving. 100 watts here stand for what? The electric power, is it not? So power in this case is 100 watts. And what else did they say about the device or the bell? They said and 220 volts. So our potential difference in this question is what? 220 volts. That is our voltage, also called potential difference. Now, what else did they say about the question? They said, what is the resistance of the filament wire? Okay, we have to find big arrow, resistance. So the resistance of the filament wire in the electric bell is unknown. So we say equals to unknown. So guys, we have successfully derived all that was given us in this very question. So the next question to ask ourselves is, what formula do you think combines both power, voltage, and resistance in it? Now, before we continue, this topic is from electricity in physics. So in case you've studied electricity or you are curious where this question was taken from, is the topic called electricity. Okay, so you can go and check it out. Okay, now the formula in physics under electricity that combines this parameter at the same time is that power is equals to the voltage squared over the resistance. This is the formula we are using. Power is equals to the voltage squared over the resistance. So now we know the formula. What next can we actually do? We are going to substitute all of this into this very formula. So we'll come here and say power. Do we have a value for power? Our power is 100 watts. So in place of 100 watts, guys, we'll be writing 100 here. I mean, in place of P, we'll be writing 100. We say it's equals to, in place of V, what do we write? 220. So I'm going to write 220. Are you seeing that? They say we should square it. So raised to power 2. Okay? Then everything will be divided by, do we have a value for our resistance? No value for resistance. So I'll leave it as arrow. What do? We continue working it out. We can say 100 is equals to 220 squared. What does that mean? Now when you're asked to square a number, it is that number times itself. So 220 squared means 220 times 220. So I'll write that out. 220 times 220. Everything divided by what? Arrow. Now since we are asked to find arrow, I have to make arrow the subject of this equation. Now what do I do to make that possible? I will say cross multiply. 100 with times arrow. The invisible or imaginary one under here with times all this. So what do we now have? We now have 100, okay, times arrow is equals to 1 times all this will be 220 times 220, because it's not going to change. 1 times any number is that same number. So how do we now make arrow subject from here? What is attached is 100. So you're going to be dividing both sides by what is attached to arrow. So over 100 over 100. So watch out. 100 we cancel 100. What is left here? You have arrow is equals to. So let's work this out here. This will be what will be here. But let's simplify it here. We can say 0 cancel 0, 0 cancel 0. Any number divided by 1 will be that same number. So we can just come here and write 22, because that's what is left here, times what is left for the second, 22. Any number divided by 1 will be that same number. So that does not matter to us here. So we can now say it's equals to 22 times 22 give us what? You can check yours out. Mine here I have 484. 484. Now do we stop there? No. We have to add the unit for resistance. And in physics, the unit for resistance or electric resistance is ohms. Ohms. This is the unit for resistance. And the symbol for it, okay, is this sign. That is the symbol for resistance, ohms. So when we are done, we add the sign to it. And that is the answer to this very question. So I hope you clearly understand how question number 4 was solved. About now, we'll be getting straight to question number 5. Alright guys, here is question 5. And it reads, a heater with a potential difference of 240 volts connected across a terminal has a total resistance of 960 ohms. Find the power rating of the heater. So we say solution. Now first thing first, we derive all that was given in this question. It said a heater with a potential difference of 240 volts. So we have potential difference symbolized by V in this question. And what's the value for it? They said 240 volts. What else did they say? They said connected across a terminal has a total resistance of 960 ohms. So we're giving resistance in this question. And resistance is big arrow, and the value for it from this question is 960 ohms. 960 ohms. Now the question says find the power rating of the heater. So we are asked to find power rating. Power rating in a simpler form is find the power of the heater. So we are asked to find big P for power. It's unknown in this question. So guys, basically we have our potential difference, also called voltage. We have our resistance, and our electric power is unknown. What formula do you think we can use to solve this question? Now this question was taken from the topic electricity. Don't forget. So you are free to check it out later. Okay, so starting from the topic electricity. Now, the formula that connects voltage, resistance, and power together is simply power is equals to voltage squared over resistance. Power is equals to voltage squared over resistance. So we circle it. This is what we are going to be working with. Now, do we have the value for voltage, resistance? Okay, we have their values. So let's substitute into this formula and find our power. You can now say power is equals to voltage is 240, and we are going to be squaring it because they said V squared. So we'll say 240 raised to power 2 over what's our resistance? Our resistance is 960. So over 960. So we progress from here. We can now say power is equals to 240 squared. 240 squared means 240 times 240. So we expand. 240 times 240. Everything over 960. So this is what basically we have from this very question. How do we now solve for that? Let's do a little simplification here. We can say 0 cancel 0. Now let's times 240 with 24. Let's see what that will give us. 240 times 24 gives us 5760. So let's divide it by 96 to get our resistance. The final answer for power, the final answer for our power is exactly 60. And because we are asked to find power, the unit we attach for electric power is watts. And that is symbolized by W. So this is what we are going to be adding. So we'll say 60 W, 60 watts, and that is the answer to this very question. So about now, guys, we'll be getting straight to the next question, question number 6. So let's see how it's going to be solved. They said, what is the cost of running of 550 watt and 400 watt lamps for 10 hours if electrical energy costs 2 kobo per kilowatt hour? So we'll take our solution now. Now in this question, we're given 550 watt lamp, 5 of them, and 400 watt lamp, 4 of them. So altogether, what is the total power? We have to get that first before we start solving. Our total power will now be equals to 5 times 50, because we are trying to get the sum of all these powers. You can say bracket 5 times 50, okay, plus 4 of 100 watt lamp. That will be 4 times 100 watts. Now, whatever we get will be the value for power that we'll be using to solve in this question. So 5 times 50, like we know, is 250. Added to 4 times 100 is 400. Now, if you do this summation, we are going to get 650. And the unit will be what? Watts. 650 watts. Let me just write it again. 650 watts. Now this is what we now have for our power. Now they now said, what is the cost of running 450 lamp, 550 lamp, and 400 watt lamp for 10 hours? So we're giving time in this question, true or true? Yes. Now the time was given to be 10 hours. Now in physics, basically, because of the nature of this question, we don't work with hour because hour is not the standard unit for time. So what is the standard unit for time? It's second. So we have to convert from hour to second. How do we do that? Whatever you have here, we have 10, we'll say times 60. Times 60. That will give us our answer in minutes. They will now say times another 60. That will now give us our answer in second. And we will stop there because second is the unit for what? Time. So let's do the calculation with our calculator. 10 times 60 times 60. That gives us, okay, that gives us 33,000 seconds. So come here and write 36000 seconds. Then we'll say comma. Now that is what we now add. In place of 10 hours, we'll be working with 36,000 seconds because they are equivalent to each other. Now what is the question? If the electric energy costs for every 1 kilowatt. Now they said if the electrical energy, so the energy cost is this. Now do we have the energy of the total power? Do we have the value for energy in this question? No. So the first thing to do, because this cost is per energy, this energy was given in kilowatt hour. So we have to first of all find energy, and not just that, we have to find energy in kilowatt hour before we can now start doing comparison to get the cost. So first thing first, let's get our electrical energy, E. Let's get our electrical energy, E. Now because we know our power and our time, power is 650 watts, time, the equivalent we are working with, 36,000 seconds. What formula do you think we can actually use to get our electric power? The formula is electric power equals electric energy, is equals to power times time, where power itself is electric energy over time. So electric energy will now be power times time. So this is the first formula we are working with, guys. Take note of this. Now what do? We are basically going to be substituting. We will now say our unknown electrical energy is equals to, what is our power? Our total power is 650 watts. So we'll say 650 times, what is our time? Our time is what? 36,000. So write 36000. So guys, we are moving on with the question. Our electrical energy will now be equals to, let's see what that will give us. 650 times 36000. Okay? 650 times 36000. That gives us 23,400,000. And this is the answer for electrical energy. But the unit in this first instance will be in joule, because the normal unit or the SI unit for what? Energy is joule. So our answer is in joule. But was the rate given per joule? No. So we cannot simply go straight and say if 2 kobo is equal to 1 whatever, this so and so will not be equal to X. Because we have to make sure that they comply. The energy has to first be converted to kilowatt before we start getting our cost, which was the original question. So how do we convert from joule to kilowatt hour? How do we convert from joule to kilowatt hour? Mind you, kilowatt hour is another unit for energy, but it's not the SI unit. The SI unit for energy is joule. So in this instance, we are going to be converting from joule to kilowatt hour. Now to do that, you divide by 3,600,000. So let's see how that works. It was based on a calculation. To convert from joule, okay, to kilowatt hour, you divide by what? Divide by 3,600,000. This is the converting factor to convert from joule to kilowatt hours. Now let's do that division now. We'll now say our energy is equals to, the value we have here is 2,3, okay, 400,000 divided by what? What are we dividing by? What is the converting factor? It is 3,600,000. So guys, that is what we now have. So next thing we do, we just simply help ourselves out by stroking out some 0. 0 cancel 0, 0 cancel 0, 0 cancel 0. This one we cancel this, and this we cancel this. So this is what we now have left. So let's continue solving our question. Let's continue solving it. We'll now say E will now be equals to, let's see what that will finally give us. 234 divided by 36. It gives us exactly 6.5. So our energy in kilowatt hour is now 6.5 kilowatt hour. Now observe something. You can see how big the value is in joule. And you can notice how small, very small the value is in kilowatt hour. That is how it is in real life cases, okay? Now we go on further from this. We now have our energy in kilowatt hour. And we're told the rate that it is 2 kobo. For every 1 kilowatt hour, you're going to be paying 2 kobo. So we'll now write, based on the rate we have here, they said 2 kobo per kilowatt hour. We'll now say 1 kilowatt hour is equals to what? 2 kobo. We have drawn the relationship between the cost of the electric, what they call it, current, the electric energy, and the kobo. So 1 kilowatt hour, which is the energy, cost what? 2 kobo. Now we have a total of what? 6.5 kilowatts. We have consumed, using this setup, 5 of 60 watt lamp and 4 of 100 watt lamp. We have ended up consuming a total of 6.5 kilowatts energy. What is now the cost we are going to pay for all this? We will say X. Now how do we simplify further from here? We cross multiply. Working with the values only. What do you have here? What do you have here? 1 times X is equals to, what do you have here? What do you have here? In terms of value, you have 6.5 times 2. So any number times 1 is that same number. So 1 times X will give us, X will be equals to 6.5 times 2. 6.5 times 2 gives us exactly 13. Exactly 13. And because this side is for kobo, while this side is for kilowatt hour, our answer will be what? Kobo. 13 kobo. So the question that says, what is the cost? Our answer to it is what? X is equals to 13 kobo. So I clearly hope you understand how these questions on the board was solved. About now, guys, we'll be getting straight to question number 7. Alright, guys, here is question number 7, and it reads: a working electric motor takes a current of 1.5 ampere when the potential difference across it is 250 volts. Now, if its efficiency is 80%, the output current or the output power is, so we have to find output power. We say solution. Now, first thing first, when you are given a question in physics, like I will always say, everything that was given in the question, write them out. So we go again. A working electric motor takes a current of 1.5 ampere. That is for current. So I is equals to 1.5 ampere, because I is the symbol for what? Current. Then I said when the potential difference across is 250 volts. So we're given potential difference, that is symbolized by V. They said the value for it is 250 volts. Now what else did they say? They said if its efficiency, so we're given efficiency, right? This is for efficiency. They said efficiency is what? 80%. 80%. Now what did they say? They said if the efficiency is 80%, the output power, so let's just say output power will be given as P subscript O is unknown, where P subscript O stands for what? Output power. Output power is unknown in this very question. So guys, this is all we are given, and we are asked to find output power. So how do we solve this question if this is all we know about the question? First thing first, this question is from the topic, the broad topic called electricity. Okay? So they are testing our knowledge of the topic electricity. Electricity. So let's see how we can actually solve this question. Now we are told that there is something called efficiency. Okay? That brings our mind to efficiency of an electric cell. Okay? Now when you ask to find efficiency whatsoever, and you are comparing power, in this case we are asked to find output power. Because we are asked to find output power, it means that the input power should be given, is it not? So let's say efficiency, like we know from the formula under electricity, is power output over power input times 100%. Okay? Either you call it power output or you say output power over input power. So this is the formula for efficiency. Now guys, what do? Do we have a value for efficiency? Yes. Do we have a value for output power? That is what we are finding. Now the big deal here is, do we have a power for input power? No value for input power. So first thing first, guys, we are going to get our input power. We are told that for the electric motor, it takes a current of 1.5 ampere and it has a potential difference of 250 volts. Now, using these two, can we get our input power? Yes. We will say input power, no matter the formula for power we all know, is equals to current times voltage. So this is the formula we're going to use to get our input power. So let's solve for that. We'll now say input power is equals to what our current. Our current is 1.5. 1.5 times what is our voltage? Our voltage is 250. So times 250. So this is what basically we have. Now we'll now say our input power is now equals to, let's get this done with, 1.5 times 250. That gives us exactly 375. And because it's power we're talking about, we add watt. But is this what we're asked to find? No. We're not asked to find our input power. Rather, we were asked to find our output power. So guys, observe something. We now have a value for input power. We know the value for efficiency. And we are asked to find output power. Can we now use this formula to get our output power? The answer is yes. So let's do that right away. Let's do that right away. Now, using this formula in place of efficiency, we are going to put 80. Okay? We say is equals to. Now, in place of output power, do we have any value yet? No. So we leave it as output power, P subscript 0, over what is our input power? From our calculation, our input power is 375. And everything should be times with what? 100. Now, if you observe something, I didn't add percent and percent. Okay? But normally they should be. But why did I not add it? Definitely because this is an equation. The percentage on this side, we cancel the percentage sign on the other side. So we are going to be left with this. Now let's solve this further from here. How do we do that? How do we do that? We can choose to cross multiply. Okay? Denominator we times the numerator here. Then the imaginary denominator, which is 1, we times the numerator here. So let's see how that will look like. It will now be, watch out. 80 times 375 equals to 1 times all of this will remain all of this. And what do we have here? P subscript 0 times 100. So guys, we are moving forward. Let's see what to do for that. Let's get the value for this first. We say 80 times 375. 80 times 375. That gives us exactly 30,000. 30,000. Now it's now equals to, watch out, what is on this side? You have P subscript 0 times 100. So guys, watch out. We are asked to find the output power. So we are not going to stop here. Rather, we are going to divide both sides. Now if you ask me, what are we going to be dividing both sides with? We will be dividing both sides with the number attached to what we are looking for. And that number is what? 100. So we say over 100 and we also say over 100. I hope you are seeing how this question is being solved. So from here, what will happen? On this side, look at what will happen. 100 we cancel 100. What will be left? You have output power, that is P subscript 0, is equals to, what is on this side? We will now bring it this way. 30,000, okay, over 100. So what will now happen basically from here is that 0 will cancel 0, 0 will cancel 0. So we have 300 over 1. I repeat, 300 over 1. Now we know from mathematics, any number divided by 1 is going to be that same number. So the final value for our output power will now be equals to 300. Okay? 300 is now going to be our answer. But do we stop here? No. We are going to add a unit. And the unit for power whatsoever, whether it's output power or input power, is always going to be what? Watt. Symbolized by W. And that is the answer to this very question. So basically, you are free to go through it and ensure you understand how this question was solved. About now, we get straight to question number 8. Let's get started. Solution. Now we read and we solve. He said, two resistors, 12 ohms and 8 ohms, are connected in parallel, okay? One above, the other below. Now, if the power developed in the 12 ohm resistor is 6 watts, the power, or determine the power developed in the 8 ohm resistor. So this is basically the connection we are talking about here. Something of this sort, okay? Now this is the first ohm resistor, and this is the second ohm resistor, okay? This is what they call parallel connection. So this is basically what we have. So if the current is coming in this place, it will decusate, it will divide. Some part will go to the 12 ohm resistor, other part will go to the what? 8 ohm resistor. So the fact is that the current flowing through the 12 ohm resistor will be different from the current flowing through the what? 8 ohm resistor. But there's one unique thing about parallel connection of resistors. Now, when resistors are connected in parallel, the voltage acting at this point is the same as the voltage acting at this point. That is to say, the voltage that flows through here is the same voltage that applies to here. So the fact is that for parallel connection in actual sense, the voltage in either of the resistors will be the same. Now let's look at series connection. Series connection, they call it series connection. Now when two resistors are connected in series, let's see what will happen. This is what you have. It will look like this. This will be the first resistor, okay? And this will be the second resistor. Now this is it. Now observe that we'll call it the 12 ohm resistor, and then this other will be what? The 8 ohm resistor. Now let's see what will actually happen right here. Now, if current is flowing in this direction, now because it's just one wire that connect both, okay, side by side, because it's one wire that connect both, the current that flows through this is the same as the current that will flows through this. So for series connection, it is the current that is same for both resistors, while for parallel connection, it is the voltage that is same for both resistors. I hope that analogy is thoroughly understood by you. So let's get on with the question. We're told that two resistors, 12 ohm and 8 ohm, are connected, in this case, in parallel. So this is something of which, this is a pictorial diagram of how they were actually connected, not this. This is what we are talking about, parallel connection. Now, we'll call this arrow 1, we'll call this arrow 2. So this is our arrow 1, and this is our arrow 2. So I will write arrow 1 is equals to, what's the value there? 12 ohms. Then arrow 2 is equals to, what's the value there? You have 8 ohms. So we are moving on. We are actually moving on with the question. We are doing fine. They now said are connected in parallel if the power developed in the 12 ohm, the one above, if the power developed in it. So because this is arrow 1, the power of it will now be what? P1. I hope that analogy is clear. So we'll now say if the power developed in the 12 ohm, that is P1, is 6 watts. That is what the value will be. Then I said determine the power developed in the 8 ohm resistor. We're talking about the arrow 2 resistor. So the power of the arrow 2 resistor could be called what? Let's just call it P2. It's unknown from this very question. I hope that is clear. Now there's something you need to know. This is a case of comparison. Okay, we are actually comparing the power developed in two resistors when they are connected in parallel. And there's a formula that applies to that. And there's another formula that applies when the two resistors are connected in series. So for parallel connection, the formula we make use of is this. Arrow 1 over arrow 2, okay, is equals to, when we are trying to get what? Our power, is it not? Is equals to P1 or P2 over P1. This is the formula we make use of. The power developed in, what do you call it? The first resistor over the power developed in the second resistor, everything will be equals to something like this. So in a better form, I will actually have to write like this so that to kind of save your understanding. I will say P1 over P2 is equals to, P2 is equals to arrow 2 over arrow 1. That is basically how the formula will look for parallel connection. So take note, for parallel connection. Then for series connection, what if they were connected in series? Let me just write it here to save my space. What if they were connected in series? The power developed in the first resistor over the power developed in the second resistor will be equals to arrow 1 over arrow 2. So observe something, okay? Kind of observe what happened here. If you look closely, you will notice that for parallel connection, arrow P1 and arrow 1 are not on the same side of the equation. P2 and arrow 2 are not on the same side of the equation. Whereas for series connection, P1 and arrow 1 are on the same, what do I call it now, upper part of the equation. But in this one, it's not the same thing. Here it is the numerator, here it is the denominator. While P2 and arrow 2 are the denominators for those. So P1 arrow 1, P2 arrow 2. Whereas P1 arrow 2, P2 arrow 1. So this is it for parallel and this is it for what? Series connection. So now guys, the big question here is, which one were we told these two resistors were connected in? We were told that they were connected in parallel connection. So this formula is what we use. We'll now come here and write, what do we have here? Arrow P1 over P2, okay, equals to arrow 2 over arrow 1. So guys, this is the formula we are making use of. So next thing to do is to impute all the values we have. Any value for P1, our P1 is 6. So we'll say 6 over any value for P2, our P2 is unknown. So we'll leave it as P subscript 2 is equals to any value for arrow 2. Our arrow 2 is 8. So we'll say 8 over any value for arrow 1. Our arrow 1 is 12. So we say over 12. So guys, that is how it is being done. That is how it is being done. Now mind you, we are asked to look for P2. So we are not stopping here. What next do we do? To solve this for that, we cross multiply. Okay? So we can say P2 times 8. I'm starting with the side that has the unknown. P2 times 8 is equals to 6 times 12. 6 times 12. Okay? So watch out from here. We are going to be looking for P2, but something is attached to it. So we have to divide both sides. Now, because it is saying times 8, we divide both sides by what is attached to the unknown. In this case, it's 8. So we say over 8 over 8. That is how it is being done. Now watch out. 8 we cancel 8. We now say, watch out what will happen now. We now say what is left here. We have P2, okay, equals to, what do we have here? 6 times 12 over 8. So basically, let's get our final answer. P2 will now be equals to 6 times 12 is what? 6 times 12 is 72 divided by 8. The answer is exactly 9. So our answer to this question is 9. And because it's power that the value is for, the unit to be what? Watt. So in essence, the power that is developed in the 8 ohm resistor is 9 watts, courtesy of the fact that they were connected in parallel. So I hope that is basically clear. So you are free to go through it and see how this question were solved. So guys, about now guys, we'll be getting straight to question number 9. Alright guys, here is question number 9, and it reads, the terminal voltage of a battery is 4 volts when supplying a current of 2 ampere and 2 volts when supplying a current of 3 ampere. Now the question is, calculate the internal resistance of the battery. So we say solution. We are taking the solution right away. Let's see what can be done to this question. Now understand something, we are comparing terminal voltage and current. When the terminal voltage is this, the current is this. When the terminal voltage is that, the current is that. So we call this first terminal voltage V1, this first current I1, this second terminal voltage V2, and this second current I2. So let's see how that works. They said the terminal voltage of a battery is 4 volts. So that will be our V1. V1, big V, not small v. Take note, it's the big V I'm talking about. They said the value for it is 4 volts. Okay? They now said when supplying a current of what? 2 ampere. So in this case, our I1 is what? 2 ampere. While our V1 is 4 volts. So that is what we're given initially. They now said the terminal voltage was not altered and it was 2 volts. So when the terminal voltage was now 2 volts, what did they now say happened? The current that was supplied was what? 3 ampere. So I2 is now what? 3 ampere. Now what is the question saying? Calculate the internal resistance of the battery. Okay, internal resistance is symbolized by small arrow. Okay, big resistance is for the external resistor, but the small arrow stands for internal resistance, and that's what we are asked to find. Now this question was taken from the topic electricity. Okay, electricity, and specifically speaking, this topic was from EMF of a battery. EMF of a battery. Now we know from that topic EMF, okay, EMF is equals to let's say I in bracket arrow plus small arrow, I in bracket big arrow plus small arrow. This is the formula for EMF. Then we have other derivative depending on what was given in the question. Now in this question, were we given our big arrow? No. So we cannot use this original formula for EMF. Rather, we will expand this further. There's another formula to use. Okay? That formula is E equals I arrow plus I small arrow. Now that is gotten by simply expanding this. Okay? Now if you still check, we don't have a value for big arrow. So what do? We know from the topic EMF of a battery that I times big arrow is the big V we are talking about. So we now form another formula and say EMF is equals to big V plus what is left? I arrow. So this is the formula I think we can actually use to solve this question. Okay? Remember, we're comparing if the big V is this, the current is that. While the big V was now altered to this, the current is now whatever they gave. So we are comparing terminal voltage, which is our big V, and our current, which is our I. And we are asked to find small r. Now because we are comparing, it means that one thing will be constant, and obviously that will be the EMF. Whether you vary the terminal voltage of a battery, two things remain constant: the value for the internal resistance and the value for the EMF. So because we now know that the EMF will remain constant, we can say the initial of all this will be equal to the final of this same thing. What am I saying is this? I'm saying V1, I'll be attaching 1 for the initial ones, plus I1. Now like I said, when you are altering terminal voltage, what remain constant? EMF will remain constant and the internal resistance will remain constant. So there's no need for me to add subscript 1 here. Rather, I will just simply say I1 times R. Are you seeing that? Is now equals to, on this same side I will replicate it here, but this time I will be adding subscript 2. What do I have? V2 plus I2 then R. And like I said, you know why I did not add 2 to here and I did not add 1 to this? Because the internal resistance will remain constant alongside the EMF. So this is the relationship I've drawn because we are comparing two scenarios. Now what else should we do? We simply impute our values. Our V1 is 4. So I will say 4 plus our I1 is 2. So 2 times R will give us what? 2R. It will now be equals to, let's see what we have. It will be equals to, what do you have? Our V2 is what? 2. So I will say 2 plus, what is our I2? Our I2 is 3. 3 times R. 3R. So guys, we have gone a long way in this question and we are actually making good progress. What should we do from here? We have 4 plus 2R equals 2 plus 3R. The best thing to do here is to collect like terms. Okay? The ones with arrow will go to one side. The one without arrow will remain on one side. So we can bring these two here. It will now be, remember there's a 4 waiting for the 2. It will be 4. When the 2 comes, it will become minus 2 equals to what is left here? 3 arrow. Now when this plus 2 arrow crosses this line to meet the 3 arrow, it will become minus 2 arrow. So guys, observe what we have done now. It's now 4 minus 2 equals 3 arrow minus 2 arrow. So guys, what should we do? We simplify further. 4 minus 2 will give us 2. It will now be equals to 3 arrow minus 2 arrow is exactly 1 arrow. But we don't write it as 1 arrow. Instead, we just put arrow. So we are in another way saying that arrow, which is our internal resistance, is equals to 2. Is equals to 2. But should we stop there? No. We are asked to find internal resistance. And mind you, the unit for resistance of any form is ohms. So it's symbolized by this. Okay, it's spelled OHMX. That is the unit for resistance of any form. So our answer is 2 ohms, and that is the answer to this very question. So you are free to go through it. About now, we get straight to question number 10. Solution. Now this one read and we solve. They said a cell of internal resistance 2 ohms. So we're giving internal resistance in this very question. Small r, which is our internal resistance, they said is what? 2 ohms. And what did they say about the question? They said supplies a current to a 6 ohm resistor. Now that 6 ohm resistor is outside of the cell. Okay? So it's an external resistor. Now for external resistor under EMF, you represent them by big R. So big R is equal 6 ohm. Now we are asked to find what? The EMF of the cell. So EMF in this, the efficiency of the cell. So efficiency in this case is unknown. Is unknown. So what do you think we can actually do if we know the internal resistance, the external resistance, and our efficiency is unknown? Now when you are comparing resistance, the formula to use to get your efficiency is going to be big arrow over big arrow plus small arrow, whatever you get from this, times 100%. That will give you efficiency. So take note of this. Remember, if you are comparing power, what should you have done instead? Output power over input power times 100%. But if you are comparing resistance, it will be the big arrow, external resistance over external resistance plus internal resistance times 100%. Okay? So let's do this now. Now we know the formula to use. Let's continue. We will now say our efficiency is equals to, what is our big arrow? It's 6 over, what is our big arrow? Again, following the formula is also 6. Then what is our small arrow? Our small arrow is 2. So guys, this is what we have. We'll keep it in brackets so we won't mix it up. Times 100%. So this is what we have. We are making progress. We'll now say E is equals to 6 over 6 plus 2 is 8. So we say 6 over 8 times 100%. So we can actually move further and say efficiency is equals to 6 times 100 is 600. So we say 600 over, what is the denominator? Over 8. Now that will now give us, let's see what that will give us. 600 divided by 8. That gives us exactly 75. So 75%. 75% is the value for the efficiency for this very question using this formula. So I hope you clearly understand how this was solved. So guys, thanks for watching. I hope you clearly understand how the calculation questions for physics calculation theory series was solved. Thanks for watching. Don't forget to share this video with your friends. I will see you guys in the next series.